Good morning, kiddos, and welcome to chapter 2. Today we're going to be talking about conditional statements. Okay, conditional statements are often known as if-then statements because they're framed like if something, then something. Okay, and conditional statements or if-then statements have two pieces to them. This first part is known as the hypothesis. And the second part is known as the conclusion. Okay, let's do a few examples. Right now, we are going to underline the hypothesis or the if part of the statement and circle the conclusion or the then part of the statement, okay? So if a polygon is a pentagon, this part came after the if, so it is the hypothesis. Then it has 5 sides. This part came after the then, so it is the conclusion. If a polygon is a pentagon, then it has 5 sides. Okay, the next one, if 2 lines form vertical angles, this is what comes after the if, so it is our hypothesis, then they intersect. That part came after the then, so that is our conclusion. Our next one, if you run, that is our hypothesis, then you are fast. That is our conclusion. And finally, if you like math, then you like science. Okay, so with each of these examples, we found our hypothesis, which comes after the if, and our conclusion that comes after the then. Now we're going to try writing our own conditional statements or our own if-then statement. So we have a statement that says today is Friday and tomorrow is the weekend. Okay, so we have 2 pieces of information. Today is Friday and tomorrow is the weekend. Okay, but the only problem is we don't know which of these is the hypothesis and which one is the conclusion. So we can actually write this statement 2 ways. Okay, so if today is Friday is our hypothesis, then we can write if today is Friday, don't forget our comma. If this is our hypothesis, then the other piece must be our conclusion. So we could say, then tomorrow is the weekend. Okay? So if today is Friday, then tomorrow is the weekend. We could write it like that if this first piece was our hypothesis and our second piece was the conclusion. But what if it was flipped? What if this today is Friday was our conclusion and tomorrow is the weekend was the hypothesis? Since we don't know which one is which, we can also write it like this. If tomorrow is the weekend, comma, then today is Friday. So we can make 2 possible conditional statements out of these 2 pieces of information. Okay, let's try that again. Here we have another statement with 2 pieces of information. You are in a band and you play the drums. So our 2 pieces of information are you are in a band and you play the drums. And again, we don't know which piece of information is the hypothesis and which one is the conclusion. So we can make 2 statements out of this as well. Okay, if the you are in a band is our hypothesis, then we can start with if you are in a band, don't forget our comma, then that means our second piece of information, you play the drums, would be our conclusion. So we could write, then you play the drums. Okay? But if our first piece of information was the conclusion, then that makes this piece of information, you play the drums, our hypothesis. So let's write that statement as well. If you play the drums, comma, then our conclusion, then you are in a band. So these are our two pieces of information and the two sentences that we can form from that. If you are in a band, then you play the drums, and if you play the drums, then you are in a band. So this time it says 9 times x plus 5 is equal to 23 because x is equal to 2. So the two pieces of information that we know is that 9 times x plus 5 is equal to 23 and x is equal to 2. Okay? So we don't know which piece is our hypothesis and which one is our conclusion. So if we use 9 times x plus 5 is equal to 23 as our hypothesis, then it would look like this. If 9 times x plus 5 is equal to 23, our comma, then our second piece of information, x is equal to 2. But if x is equal to 2 is our hypothesis, then our statement would look like this. If x is equal to 2, comma, then the other piece of information, then 9 times x plus 5 is equal to 23. So the two statements that we could make out of these two pieces of information are, if 9 times x plus 5 is equal to 23, then x is equal to 2. Or, if x is equal to 2, then 9 times x plus 5 is equal to 23. This one is a little bit harder to find the two pieces of information because there's no comma to tell us where the two pieces split, like the last three examples. So, let's take a look at this. The measures of complementary angles have a sum of 90 degrees. Okay? So, I see the two pieces of information as there's a pair of complementary angles and they add up to 90 degrees. Okay? So if I want to use the fact that they are complementary angles as our hypothesis, then I could write this. If we have complementary angles, comma, then they add to 90 degrees, or then they have a sum of 90 degrees. But if I wanted to use the fact that they add up to 90 degrees or have a sum of 90 degrees as my hypothesis, then it would look like this. If they add to 90 degrees, don't forget our comma, then we have complementary angles. So the two conditional statements that we could form out of these two pieces of information are, if we have complementary angles, then they add up to 90 degrees, and if they add to 90 degrees, then we have complementary angles.